Oi, gente. Agora vai ser a palestra do Pablo Samuel Castro. Ele é um pesquisador do Google Brain, que é um dos principais labs de IA da Google, lá em Montreal. Ele nasceu em Quito, no Equador, então ele é da América Latina, que nem a gente. E ele fez doutorado na Universidade de McGill, no Canadá. E tanto o doutorado dele quanto a área de pesquisa atual dele é aprendizado por reforço, que é uma área muito legal de inteligência artificial. Além disso, ele está hoje em dia se esforçando bastante para tentar ajudar a galera da América Latina a entrar mais para essa área de aprendizagem de máquina e IA moderna. E ele é um músico ativo, ele adora muito música, que nem a gente vai ver na palestra. A palestra está em inglês, ela foi pré-gravada para a gente poder fazer legendas e ficar mais acessível para todo mundo. Quando terminar a palestra, ele vai entrar aqui na call com a gente e vai tirar as dúvidas. Vocês podem fazer as perguntas tanto em inglês quanto em português, que se mandar em português a gente traduz na hora de perguntar para ele.
Hello everyone, my name is Pablo Samuel Castro. I am a staff research software developer in Google Research, Google Brain in Montreal. This is my first time pre-recording a talk using new software, OBS, so I hope it runs smoothly. So today I'm going to talk to you. Thank you, by the way, for inviting me, first of all. It's a real pleasure to be able to speak to you, even if it's just virtually. And so today I decided to talk to you about computer science and creativity, which are two things that I'm quite passionate about. And so really the kind of overarching theme of this whole talk will be these two things: learn, then create. I think this has been, as I prepared this talk, I realized this has sort of been the motto throughout my life. And I'm happy where I am now, so I hope this serves as inspiration or motivation or something to have as a reference. So I'm going to give you a brief outline of what I'll talk about. So first I'll start with my origins, so where I came from, where I'm from, and sort of my career trajectory to where I am now. This includes talking about obviously computers and music and how they fit into my life. They've been a part of my life since early years. I'll talk about university years, both my undergrad and my postgraduate degrees, as obviously they're very important to where I am now, which resulted in me joining Google. And then I'll conclude with some projects that I've been working on over the past few years that I feel unify these topics of computer science and creativity quite well. So to start off, I'm originally from Quito, Ecuador, which is not far from Brazil. So I was born and raised there. I grew up mostly speaking English in my school, but at home and with all my friends in Spanish. So both of these languages have been kind of native languages to me from the beginning. I also grew up in Guayaquil and Miami and Puerto Rico for a little bit, but mostly in Quito, and that's where I was born. Okay, so since I was basically born, I've always been fascinated with music. Music has always been something that I've been drawn to, and I've gotten a lot of pleasure out of it. And then as I grew older and computers actually came around, because when I was born, computers weren't readily available, computers became an important part of my life. So music, as I said, I've been playing all of my life. I started with piano, then I went on to guitar. I had a rock band in high school that was really fun. And then at high school, we got our first computer, the Apple IIe, which I'm showing here. And this was, for me, just mind-blowing, because as I played with it, I realized that I could make things with this, more than like just Play-Doh or things. I could make games, which I was really interested in, and I could make movies, animated movies. It's something that really fascinated me, and Macromedia Director 5 was the software I used back then, and looking through these images still makes me nostalgic. So I basically had to code up every single frame and draw things. I wasn't quite using programming yet, but it was starting to get me excited about this idea of using computers to make things that I wanted to make, that I couldn't just draw and have it be reproduced in a faithful way. I think that's what drew me really to computers, that you could, if you well, nowadays write code, or if you could design this graphic and the animation scheme, then you would basically be able to reproduce that every time. And so these two things, music and computers, as I said, have always been a big part of my life. And this is essentially what two of my rooms look like at my house nowadays. On the left, this is my desk where I'm speaking to you from right now. And on the right, that's my music room. And those aren't even all my instruments. I have been collecting instruments all my life, and I love playing music. It's a big part of what I do. Okay, so after high school, I moved to Montreal to do an undergrad at McGill University. So at the time in Ecuador, computer science wasn't really a thing that people talked about or knew much about. So I didn't really know what it was. I just knew I wanted to work with computers. So I joined actually the management faculty in information systems. And when I joined, it became pretty clear to me very quickly that this wasn't what I wanted to do, as that was more using computers for management tasks, which wasn't what I was interested in. I was really interested in learning more about computers and programming and those types of things. So I found computer science, and luckily I was able to transfer. And so I did my bachelor in computer science. I got really interested in math as well. Even though I was always interested in high school and university, I really discovered how beautiful it can be. I had a few good professors that really drew me to it, a few really bad ones as well. I failed calculus one year. So then I just got more and more excited by this topic, and I decided to do an honors project. And I did my honors project with Doina Prekup, who was, she had just joined McGill as a prof, and she was teaching the first artificial intelligence course using this book over here, the one in the middle. And that kind of blew my mind. I didn't know what AI was before then, and it was just really exciting. So I decided to do my honors project with her. My honors project was basically designing this neural network, which I have this little cartoon here. The idea was that it would be able to improvise jazz. And so since then, I was interested in this intersection between computer science and machine learning and music and creativity. So the way the network worked is I basically coded up the network myself. So this was a time way before TensorFlow or PyTorch or any of these things were available. So I had to code up each neuron independently with C++ and basically design backpropagation, code it up by myself. So it was a really learning experience. And so the idea was that you'd feed in a chord sequence like we have on the left here. It would go through the network, and then it would produce some melody. And so then I'd grade the melody. I'd say whether it was good or not based on the chords, and then that is what the network would use to sort of, as its loss, to do the backpropagation. And so as you can imagine, that took a really long time, and the network really didn't get anywhere, didn't produce anything very good, but it was a really good learning experience. And so these are some of the books three of the books that I fell in love with during my undergrad. I'm just going to move myself over here so you can see the third book. So Algorithms, although I've been told this is not the best book, I enjoyed it. Artificial Intelligence by Russell and Norvig, and Introduction to the Theory of Computation by Sipser. This was taught by Prakash Panangaran, who was a prof that I really, really loved, and I loved his way of teaching, and he got me really excited about computer science and math. So anyway, I graduated, and then I joined this company called CAE that they were still in Montreal, and they built flight simulators. So it was a fun job. My job was mostly porting code from Fortran and running in these really old machines into new Linux boxes running in C++. And so what was really cool about it is I got to travel all over the world to perform these migrations of code. But after 4 years, I started getting a bit restless, and I wanted to learn something new. And so I started secretly rereading this book of AI. And also I read this book by Douglas Hofstadter, Gödelischer Bach, which if you haven't read, I highly, highly recommend. That book kind of changed my life, because the way he presented this intersection of math, computer science, art, and music in what he calls the eternal golden braid was just mind-blowing to me. And it just was so beautiful, and it made me realize there's so much deep beauty in math, in computer science, that obviously we also see in art and in music. And so this really got me thinking that I wanted to try something new. And I luckily ran into Doina Prekup, who was my prof, my first AI prof in my undergrad, and she said, "Why don't you come do a master's with me?" And so I did. I quit my job and rejoined McGill to do a master's. And so I chose my supervisors over my topic. I really liked doing this style of teaching, and I really loved AI. So I knew I wanted to do something in AI. And as I mentioned before, Prakash was just a great prof, and I really wanted to work with him. And I knew he was really rigorous mathematically speaking, so I would be able to definitely learn a lot. And so as I had been reading this AI book, I got really excited by evolutionary algorithms, and that's kind of what I wanted to do my research on. And so when I approached them, Prakash balked at that idea because he said you can't do anything with evolutionary algorithms in terms of proving theorems. They're just really hard to work with, so I'm not going to do anything with evolutionary algorithms. And so I decided to not do that, and I chose, as I said, chose the supervisors over the topic. So I went with what they were working on, which was reinforcement learning and metrics and similarity metrics between states in Markov decision processes, which I won't get into now, but it's something we can talk about some other time. So I did a master's first. The title of my thesis was Bayesian Exploration in Markov Decision Processes. And so the three books that I looked at the most during my master's were Reinforcement Learning by Sutton and Bartow, which is a canonical book if you want to learn about reinforcement learning, Markov Decision Processes by Puderman, which is a very mathematical treatment of MDPs. Again, highly recommended, and Linear Programming by Vasek Shvatal, which is something that was very core to the work I was doing for my thesis. So again, the reason I'm putting up all these books throughout these slides is because all of these books influenced me in very deep ways. And as I mentioned, this learning process, at each step in my career, there's been a big learning process that has opened up new doors and allowed me to explore new ideas. And so this linear programming idea is something that was suggested to me, but really going into the depths of the mathematical theory is where I was able to come up with the ideas that I used for my thesis. And so after finishing my master's, I continued with my PhD with the same supervisors and the same university. I guess it's mostly suggested to change universities, but for personal reasons, including a band that I was playing with at the time, and I had a girlfriend at the time who is now my wife, I decided to stay in Montreal, and because I enjoyed working with Doyen and Prakash, I just continued my master's with them. And so my PhD was titled On Planning, Prediction, and Knowledge Transfer in Fully and Partially Observable Markov Decision Processes. So again, still in this topic of reinforcement learning mixed with distance metrics between states in these formal systems that we studied. So the three books that I was, in addition to all the previous books that I mentioned, the three new books that I started studying a lot during my PhD were a book on topology, infinite dimensional analysis, and real analysis. So here I really started getting deep into the more advanced math topics like real analysis and things like that. And it was just so beautiful to me, and Prakash was a great mentor in helping me navigate these sometimes daunting mathematical terrains. So learning never stopped, but also the music never stopped. So I had a very big progression in terms of music appreciation and music understanding from when I started my undergrad, where I was listening to Beatles and Fish and these kind of jam bands type things. And I had a band that I'm showing here at the top called Jai Guru, where we recorded an album. It was super fun. But as I started playing more and more, I started again wanting to be challenged a bit more musically and in terms of what I learned. So I started looking into jazz a bit and trying to teach myself the theory of jazz and how to improvise in jazz. I had never really paid much attention to jazz before. So that led me into Frank Zappa and Mahavishnu Orchestra with John McLaughlin and Chick Corea and things like that. And through Chick Corea, actually, I got into salsa and Latin music because I didn't really listen to any salsa, even though I'm from Ecuador. In the highlands, it's not that common to listen to salsa music. So I really learned to appreciate that music through Chick Corea and his jazz approach to salsa. And so that got me into people like Rubén Blades and Astor Piazzolla, Chucho Valdés. And eventually I switched bands. I formed a new band called Ecos de Porto Alegre. We played in the Montreal Jazz Festival. It was fantastic. And it was really a mixture of jazz and Latin salsa music. So again, there's books here. All of this happened because I was reading a lot and learning a lot and sort of pushing myself to learn new things. And it's through this learning process that I feel I progressed musically, and I was able to do a lot more than what I would have been able to do before. So once my PhD was done, I did a quick postdoc, which I'll skip for purposes of time, and then I eventually joined Google. So I moved to Pittsburgh in Pennsylvania to join Google as a software engineer. So at that time, machine learning wasn't what it is now. It wasn't as popular, especially reinforcement learning. Very few people were paying attention to it. And so I had a really hard time finding a job in academia, which is what I wanted to do. So I decided to join Google as a software engineer, and I joined the ads team. So I was still doing machine learning, but more applied. So we were building machine learning models for predicting click-through rate. So what that means is, if you've probably seen when you do some type of Google search, you'll sometimes get some ads that show up. So these ads are undergoing an auction, and this auction is basically all the advertisers are placing bids, and our models, our machine learning models, give a signal for how likely it is for this particular user to click on that ad. And so this model that we were building, these models that we built, are the main component in this auction. So it was really neat to be able to work in this core part of Google, and this core part of this ads ecosystem, which is extremely complex. And so I learned a ton there, both about programming and machine learning in practice. And still, I can't talk much about it because a lot of it is proprietary. But again, one of the things I really discovered in this stage of my life is that programming is really just problem solving. So if you like puzzles, or if you like Sudoku or whatever, that's all you're doing all day. And one day I just realized this, maybe it's obvious to most people, but I realized that I'm just going to work to basically solve fun problems with code. And so even though I had to leave academia at that point, for me it was fine, because I really loved what I was doing, and I loved the type of work I was doing. So in Pittsburgh, I continued with music, and again, continuing to try to challenge myself and learning more. So I formed this jazz piano duo that I'm showing here at the top left. And through him, I started listening to a lot more jazz trios and thinking about composition and arrangement. And the bass player that I was playing with, his father was the main trombone player with the Pittsburgh Symphony. So I started getting really into classical music, which I always listened to throughout my life, but I started studying it more and trying to learn the compositional aspects of it and the arrangement aspects of it, and trying to incorporate that into both my compositions and arrangements in jazz and also my improvisation. So I feel like I grew a lot as a piano player there, as an improviser. Comparing the videos I've made of myself from before I moved to Pittsburgh and after, the improvement is obvious. So after 4 years in Pittsburgh, we decided to move back to Canada. And so I joined the Google office in Montreal. And then I eventually was lucky enough to be able to join research at Google, so specifically Google Brain. And I joined Google Brain to do reinforcement learning, which is what I had done my PhD in. So I was really happy. I thought I would never go back to that topic again after having unsuccessfully tried to find a job in academia after my PhD. So I was really happy to do this, but this was before I left academia, there were not many deep networks out there. It was still not proven that they could work very well. And when I rejoined research, everybody was using deep networks. So it was a bit of a learning curve, but it's been a really fun ride. And so one of the things that was, for me, really interesting is, in addition to just moving to deep networks, the progress that was made in terms of generative models, especially for music, was just amazing for me. So there were some generative models when I was doing my PhD. There were still, like Douglas Eck was doing a lot of work in this space at Mila in Montreal. And he eventually left Mila and joined Google to form the Magenta team. And so this team was really tasked with exploring this space at the intersection of music, art, machine learning, and creativity. And so before when I was doing my PhD, the type of generative models we had available were pretty basic. And not very exciting. I wasn't too interested in working with them, but when I saw what they had when I rejoined research, it was just amazing. And so that I started exploring that space a lot more, and I really saw these two parallel paths of music and computer science starting to meet for me, even though obviously there were a lot of people that had already been working on that a long time. And so another thing I discovered when I rejoined research was Twitter. So I had opened an account years ago, but I never used it. And then I realized that all the cool kids in research are using Twitter. And so when I rejoined that, when I joined Twitter actively and started to become active, I realized that there are a lot of people out there that are putting things out, trying out like cool projects and just putting it out there to the world. And I had never really thought of doing that. The only way I thought people would put out projects is if you start a company and you try to get funding, and I didn't really want to do that. I was happy with Google. But then I realized there's a lot of creative things you can do aside from music that you can put out and people enjoy. So that really got me excited, and since then I've been, in addition to the reinforcement learning research that I do on a day-to-day basis, also just kind of exploring this creative outlet using computer science. And so now, having gone through that long trajectory, I'll give you a little bit of a taste of some of the projects that I've been working on, and I'll explain a little bit how some of these work. So the first project that I took on was this idea that I had after reading this Wikipedia page about some weird language somebody had created years ago, or centuries ago, that was called sol re sol, and the idea was to be able to convert words to music and colors to music. So have music be this, music and color be this universal language that you can communicate in or sing in. And so obviously it didn't really take off, but the idea I thought was really interesting. And so I wrote this this web application where basically you could feed in a MIDI song, and it would convert that, so the notes here, it would convert that into colors. So the piano keyboard at the top shows you the color that you have for each note in a piano, and that's how a MIDI song gets converted to piano. So I will see if this works. That works, but that's not the page I wanted to show. So I am going to show you what that looks like. So we'll take, for instance, Beethoven's Fifth Symphony. And so when you convert Beethoven's Fifth Symphony, the first movement, this is what it looks like with this system. So when I play, you'll see where all the notes fall in this well-known melody. There, so there's a bunch of songs you can play with if you go to that site, which will show up here. And so in order to be able to do that, I had to learn a lot of JavaScript. I had used a little bit of JavaScript before, but not nearly enough. And so that, again, was another big learning experience. So one thing that I found neat was that we could go from music to colors, but I was interested, could we go from like a painting into music or sounds or something? And so I did that, but here I ran into a problem that there's 88 keys in a piano, so there's 88 notes, which means that there's 88 possible colors. But in a painting, obviously, we have way more colors available to us. So how do I convert all of these colors into notes? So for that, I ended up using KD trees so that we could find the nearest color in whatever color is given to it, to be able to map onto a key. And so again, this is something I learned in my undergrad, but having all these tools around and learning about these tools allows you to creatively tackle some of the problems that you need to solve in order to be able to express yourself creatively. So I'll just show you what that looks like, or what that sounds like. So we can take some preloaded image. So let's take the Starry Night that I was showing you before. And so if we play it, this is going to sound pretty chaotic, but just to give you an idea. Sorry about that. It's not necessarily dinner music, but the idea I thought was interesting, to be able to go from painting into sound. And so obviously there's more you can do with it that would make it sound a bit smoother and a bit nicer. And some people have suggested a few things, but I haven't had time to really implement them. So that I learned a ton about JavaScript there, and music in JavaScript and all the different libraries that you could use. And this idea of being able to interact with the browser in a creative way really appealed to me. Here was a bit less interactive because you just fed in a song and then the algorithm did its thing. So then I built this other thing called a musical aquarium. And so the idea here was that whenever you clicked on the mouse, these fish would appear, and each fish gets a note from a pentatonic scale. So that means that all the notes will sound nice together, in contrast to that thing I played for you before with the Starry Night. And so these fish float around, and the longer you hold it, the bigger the fish, and whenever they collide, they sing. So I'll show you what that sounds like. Come back here. So I'll just start clicking, and you'll see the fish start appearing. So because it's all a pentatonic scale, they mostly sound assonant, so not consonant, sorry, and not dissonant, which makes it kind of nice. So that was really more of an experiment in this interactive way of generating sounds or generating music. But it also taught me a lot about P5, which is a library in JavaScript that allows me to draw these things kind of naturally. So you just draw the shape of a fish, and then you can easily draw a new fish with different colors and different sizes without having to redraw it every time. And so that led me to my next project, which I called The Cost of Beauty. And so this was again inspired by another book I read called The Evolution of Beauty by Richard Prum, which I highly recommend. And so in this book, Prum explores this idea of aesthetic evolution. And so this goes beyond the typical adaptationist evolution that we've heard of, where it's kind of like survival of the fittest. And so the idea here is that he's exploring and proposing is that females throughout the evolution of all the species in our planet have an aesthetic preference for certain type of males. And so this is what leads to, for instance, birds being very pretty and very ornamental, which can often, those ornaments can often work against them in terms of survival of the fittest. And so I wanted to explore this idea with one of these web apps, which is what I'll show you now. Just a second. Not that one, not yet. So what I'm going to do is I'm going to make these things go really fast so that we can see them evolving very quickly. And here I was coming back to this initial idea of evolutionary algorithms, which is what drew me sort of to come back to grad school and machine learning and all that. So I'm going to set the cost to be really low. What this means is the higher the cost, it means that the more colorful or the prettier you are, the faster you die. So the lower the cost, the longer you can survive, and so you have a greater chance of spreading your colorful genes. And so the way that this is going to work is you have, I'll just pause it for a second, you have males, which are like this one that I'm highlighting here, and females, which are more concave, I guess. And so the females get to pick the males. So the males are always trying to, I'll do a show beam. This will sort of show a red line when it's trying to reach a female. If it shows the line, it means the female accepted it. And the females will accept the most colorful mate that's proposing. And so when a female accepts a mate and the male is able to catch up to it, they'll reproduce and the colors will be passed on. And so you'll see this happening. I'll try to pause it when some are reproducing. So you can see here, there's a male and female reproducing, so you'll see that they spawn new children and they inherit the colors from their parents. And so you can see over here the colors that are evolving. So one thing I also coded up is as you start adding more and more of these things, it starts getting overpopulated. And so I simulated overpopulation and the catastrophic effects it can have. And so half of the population dies off at one point, or more than half. And so what's interesting there is that the ones that survive, the things, or these little creatures that survive, the colors that they have kind of determine the colors for all the generations to come. So you can see that they ended up kind of converging to this orangey type color. And every time you do it, it's a different kind of color. And I find this kind of peaceful to watch and sort of mesmerizing. It's this sort of evolving art that's based on these very simple rules, but that can lend themselves to very complex dynamics. So this is something I'm really interested in, simple rules that lead to complex behavior like this, and can often be very pretty behavior. Okay, so I'm going to close this here and talk about the next project, which here I started exploring a bit more machine learning and how we can use the process of learning in a creative way. And what I was exploring here is can we listen to machine learning, so a computer learning. And so I call this the sound of learning. And so what this is trying to do is we have this red polynomial function, this blue polynomial function, and we're trying to fit the red polynomial function onto the blue. So we're going to just use TensorFlow. This is a very simple learning problem. But what I did here is the way a lot of these learning algorithms work is that there's a loss function that tells you basically how far away you are from the right answer. And so when this red curve will fit the blue curve exactly, that means that the loss is 0. And so what I did is I took a simulated guitar, and each of the strings in the guitar, there's 6 strings, I detune it by an amount proportional to the loss. So the larger the loss, the more out of tune the guitar sounds, and when the loss is 0, the guitar sounds perfectly in tune, like an E major chord. So let's listen and learn. It went from dissonant, so very dissonant, to this nice consonant E major chord, and so you can hear the learning process happening. So this idea of using the learning process in a creative setting for sound or for visuals is something I'm still exploring for my own performances. Okay, so let's go back to the slides. Okay. So the next project I want to show you is this thing I built called ML Jam. And so the idea here is that I wanted to continue exploring using machine learning in this creative process and in a performance setting. So what I did is I took two machine learning models, one that's able to generate new drum beats based on existing drum beats, and one that's able to generate new melodies based on existing melodies. And so this is a paper I published at ICCC, which is a computational creativity conference. I published this last year. So I wrote a blog post about it that you can check out, and you can obviously check out the demo, which is what I'm going to show you now. So in this demo, what we're going to do is we're going to start the click track, and then I am going to record a bass line with a MIDI keyboard that I have hooked up here. So now what I'm going to do is I'm going to create what I call a deterministic drum beat. So this means that for each bass note, it's going to match a snare hit, and it'll just sound funky with it. But there's no machine learning here. It's just a algorithmic way of generating a drum beat. So I'll start that now. So this sounds pretty good. So now what I'm going to do is I'm going to send this beat to the machine learning model that I mentioned, and the machine learning model will generate a new beat that hopefully still matches pretty well. It's a bit busier, but still works pretty well. So I'm going to turn off the click. And I'm going to record some chords. And now finally I'm going to play the lead guitar, the lead keyboard. So I've played all these notes, and these notes will get sent to a buffer, or stored in a buffer, and this buffer gets sent to my machine learning model that based on these notes, it will generate a new melody. And then when I play, the machine learning model intercepts my notes and replaces it with its own notes. So I control the rhythm, and the machine learning model controls the notes. So what I'm going to do is I'm just going to play the same note on the keyboard. And so when you see the red keys show up in the keyboard here, that's the machine learning model choosing the note. So I choose the rhythm. So if there were no machine learning model, you'd hear the same note over and over. But because the machine learning model is picking the notes, you'll hear different notes. So let me start that now. So So right now it went to the machine learning model, and now it's generated new notes. And I'm just going to play the same note over and over, but you'll hear different melodies. So I'm back to playing myself. Let's send that to the model again and see what it comes up with now. All right, let's stop that. So that's really just an initial experiment in this idea of trying to combine machine learning in a performance setting, in a live setting. And I've actually used this this model with my trio, and I've performed with it live. And it works okay, but it still needs a lot of work. I obviously don't use the browser version when I perform live. I use a Python version that works a lot better. Okay, so I still want to go through a few more projects. I'm going to go a bit more quickly now. One of the projects that I'm still working on, I'm quite excited about, I call Ganterpretation. And here what I'm doing is I'm taking some audio signal. It could be myself performing or voice or whatever, and I try to extract a signal from it, a one-dimensional signal, that then I use to control the generative process of a generative model. So what I mean by this is I take, for instance, the audio of me playing piano, and I extract the spectrogram from it using a fast Fourier transform. And then from this spectrogram, I can take for each time slice, compute the total variation from one time slice to the next, and that's what I plot here. And so then I have this algorithm that tries to find inflection points, which are points where this one-dimensional signal changes for quite a bit. And so I'm going to use these inflection points to pick categories. And the categories I'm picking are ones that come from this generative model that's called BigGAN. And so this was published a few years ago by DeepMind. And so this is a model that is able to generate very realistic pictures based on certain categories. They have 1,000 categories to choose from. So for instance, this dog and this hamburger and this weird tennis ball, they were all generated by this model. So the model dreamed this up. These images did not exist before. So the model was trained on a bunch of images, and then it's able to generate new images or imagine new images. And so what I did is I use my signal here on my inflection point so that each inflection point maps to a category from this model. And what's neat about this model is because it's able to generate all these images, it can interpolate between images quite smoothly. And so I use this signal to sort of control the interpolation and how the images will move between these categories. And so that's what I'm going to show you now. This is a interpretation of one of my arrangements it's a mashup of Johann Sebastian Bach's Prelude in C-sharp minor and Paul McCartney's Blackbird. So you'll see on the left the GAN interpretation. So you see it's basically moving changing the interpolation based on the audio that's coming. So here it's interpolating between a salt shaker and a colander or something. So I'm going to fast forward to my favorite part of this interpretation. So here it seems like it's interpolating between a lighthouse and a lighter or something. So what I really like is when there's silences, because you get it to pause on an image, and you'll see that happen here. It's pasta. So this is a project I'm still working on. I'm still quite excited about. I'm hoping to release the code pretty soon. And I'm working on a way to be able to use this live, because this process of generating these videos takes quite a while. It takes multiple hours. And then so finally, I just want to talk about two projects that I've been working on the past few weeks during this quarantine. One I call Bach Backwards. And so what this is this idea of trying to get more out of musical performance than just the audio, but also generate visuals that accompany that audio, and then try to do funky things with it. Again, using some of the sorry, that's not the right one. Some of the concepts that we learned in computer science when we were learning all of it. So this is not using machine learning; it's just using good old computer science techniques. So what you're going to see here is me playing Bach invention, and there's going to be visuals that come from my performance. So each note I play produces one of these little spinning spheres. And so what's cool about this is I can store all of these in a buffer and then do something else with it. So what I was exploring here and why it's called Bach backwards is that then I can, once I finish performing that invention, I can then ask the model to play that in, the system to play it in reverse. And so you can hear Bach backwards. So that's what I'm going to do here. And all the spinning things come back at you. So you can see it sounds kind of weird because the dynamics are performed backwards, but it's still, Bach is such a genius that it still sounds quite nice, even played in reverse. So these ideas are just things I'm exploring and sort of trying to see how I can use these computer science techniques and the programming that I know to come up with new and creative ways for artistic and musical expression. Okay, so the last project I'm going to show you is this thing called, I call piano pendulums. So the idea is you have this pendulum swinging around, and every time I play a note on my MIDI keyboard, it's going to create a new ball that is hanging off of that pendulum. And so the double pendulum dynamics create these interesting graphics. And so as long as I hold on to the key, the ball will stay attached, and when I let go, it sort of floats off based on its momentum. So the angle at which each of these balls is added is based on the pitch that I play, and that's based on a clock because there are 12 pitches in a scale. So that's how I use to define the angle relative to the original pendulum which it's added. So I'm just going to reset this and try a new performance. So let's see. So what I love about this is that the musical performance is what's driving the visuals, but then as I see the visuals, it's affecting how I perform, because I'm trying to get some type of movement or dynamic. And the more you play with it, the more you kind of get familiarized with what type of intervals or what type of combination of notes might lead to certain visuals, but it's always very difficult to predict because again, simple rules for these pendulums, but the resulting dynamics can be very complex and difficult to predict. But I think it produces some kind of nice visuals, and so the idea is to basically end up with a painting to accompany a performance, and the painting is almost irreproducible because it depends so much on the current dynamics of the pendulum and how you perform. And with that, I'm going to turn this off, and I am done. So thank you very much for listening. I hope this was enjoyable, even though if it was virtual, I wish I could meet you all in person, but maybe at some future date. Thank you very much to the organizers for inviting me, and I hope our paths cross in the future. And stay creative, stay excited, and stay learning. Stay healthy and stay safe. Hope to see you all soon. Bye.
Okay, we'll go online. Okay, so hi everyone, this guy is Pablo, and I'm going to ask a few questions now. Marina asked, when should you choose your advisor over the research topic? I mean, you did that during your career, and when do you think people should follow the same plan?
So I guess the question is, when should you choose your advisor over your research direction or vice versa?
Yeah.
I guess if you have there's a lot of factors that come in there. There's no one right way to do things. So for instance, in my case, I had already done my undergrad at McGill. So if I would follow the recommended path, I shouldn't have done grad school at the same university. I should have gone somewhere else. But I think I may have mentioned this in the talk. At the time, I was dating somebody that then became my wife, and I was playing in a band that I was really excited about, so I didn't want to leave Montreal. And so then that already puts a constraint that I was going to stay in Montreal, and there I basically had two universities that I would have picked from, Université de Montréal and McGill. And because I already knew the profs at McGill, I just gravitated towards that. But I think independent of any personal constraints that you may have, I'd say probably pick the topic that you're most interested in if you can go to wherever you want, because you want to be passionate about what you work in. And I was lucky in that what I ended up working in, I was passionate about. But you want to make sure that whatever you're working in really drives you and pushes you to just do the best you can. So the other thing is, if you find a topic that really interests you, it may come in conflict with supervisors you may want to work with. Like, for instance, I gave the example, I was really interested in evolutionary algorithms, but Prakash told me, no, I'm not working in that. So you may come across these forks in the road, and I could have said, okay, well, I'm going to go find another supervisor that wants to do evolutionary algorithms. But I decided to stick with Prakash. So depending on how flexible you are in terms of logistics, if you have a topic in mind that you really like to study, then you can go through papers and try to find who are the main people working in this field. Are they profs? Where are they teaching? Are they taking new students? Could I feasibly go to that university, and then sort of start from there?
Thanks. David asked, how was your research path to get into a company like Google? Do you have any tips for doing that?
So I didn't join Google as a researcher. I joined as a software engineer. So when I joined Google, I was supposedly on an academic path where I was going to hopefully become a prof. This was at a time before you had all these big researchers working at the big companies like Google and Facebook and Microsoft and things like that. So really, if you wanted to do research, you stayed in academia and you stayed in universities. But at the time, it was difficult. There weren't that many jobs, and I was working in a kind of niche field that not many people were interested in. So, but I did a PhD in computer science, so I had the skills necessary to work at a place like Google. But it wasn't like an easy thing. Like I did prepare myself a lot for the interviews. I studied for weeks before. I practiced coding for weeks before. I have a blog post even where I wrote about sort of my experience going through that and tips for people that are preparing for interviews and preparing your CVs. So that is how I ended up at Google as a software engineer. So I was still doing machine learning, but it was in an applied setting. So it was because I did a PhD in machine learning, I knew how to apply these things, but I wasn't doing research. So it was more building tools for doing fast inference or doing more feature engineering because we needed fast inference for ad systems. And then I spent 5 years as a pure engineer at Google. And the opportunity opened up to join research. And because I had a PhD, sort of I had the necessary requirements to take that path. So I think it goes along with the theme of my talk. It's just really learn as much as you can and be prepared as much as you can. I thought I would never look at the topics that I studied in my PhD. Once I joined Google, I thought I would never touch that again. And now that's what I'm mostly focusing my research on, which is really exciting and interesting. But if you had asked me 2 years ago or 3 years ago, I would have said, there's no way, like I'm never touching that again. So yeah, the more you build up, even if it doesn't seem like it's going to be put to any use right now, it may come in use afterwards. So one thing I say a lot is whatever career or path your life takes you, like I'm pretty fortunate where I ended up. And a lot of it is luck, for sure. Like there have been a lot of things in my life where I've been lucky. And but the key is to be prepared when you have those lucky breaks, right? So when the research opportunity opened up, if I hadn't had that PhD, even if that opportunity was there, I probably wouldn't have gotten that job because I wasn't prepared for it. So be prepared for those lucky breaks.
Lady luck favors the prepared, right? Something like that.
Yeah, exactly.
So Luciana asked if you use processing, but you said you mentioned processing on your talk. So why don't you speak a little bit about what is processing and stuff like that?
Processing the programming language?
Yeah, P5.
Oh, so okay. So processing is different than P5. P5 is sort of like the JavaScript version of processing. I have used processing. So processing is Java based. And that I used years ago in my undergrad. It's an old programming language. It's really nice. Allows you to do some really nice visualizations. I haven't used it in many years, aside from P5, which is I guess it's kind of similar, but it's from what I understand, it's a bit different than pure processing. The other thing is, from what I understand, processing isn't as well maintained as it used to be. I may be incorrect, but this is somebody that uses processing regularly was telling me, and so he's a jazz piano player that does a lot of visualizations as well. He's been using processing, but he told me he was going to switch to open frameworks because processing, I guess, isn't as well maintained. So when I wanted to move out of the browser and starting to write programs, which are some of the programs I showed at the end of my talk, I went straight to open frameworks because of this comment on processing. So like with most programming concepts, once you have the core knowledge and the core skills of like how programming works and object-oriented programming and things like that, what language you use is not that important. At that point, it's really just syntax. So whether you use processing or open frameworks or whatever, it's just a matter of getting comfortable with the syntax. And the concepts are the same. So it's easy to kind of port from one to the other. So as an example, Box 2D, which is this physics simulator, I think it was originally designed for processing, if I'm not mistaken, but it's been ported. So I use it in open frameworks. There's Box 2D for JavaScript. And a bunch of other language. Yeah. So, at that point, it's really just a matter of getting familiar with the syntax and whatever you're most familiar with. So.
Okay. What advice would you give to someone who wants to start studying AI?
I would say don't try to shortcut the fundamentals, which are maybe less flashy than the deep network stuff. Most of the ideas that we're using nowadays and that are producing these incredible results are based on very old ideas. So backpropagation, Jeff Hinton introduced that in like 88 or something. Neural networks themselves, they've been around since the 1950s. Reinforcement learning, which is what I work on, has been around since the 1980s. It's just that now we have the compute to actually do interesting things with them, whereas 10 years ago, we didn't really have that. There's obviously been a lot of other advances. It's not just compute, but the core ideas still stem back to decades ago. And so really understanding those core ideas is I find is fundamental to doing deep research, pun sort of intended. So a lot of it is linear algebra. So really understanding linear algebra well. When I was studying linear algebra, I didn't really appreciate what I would use that for eventually in my undergrad. And I wish I would have paid more attention now, because there are certain basic concepts that I've had to sort of revisit now to get more familiar with them, because I just did enough work to get the grade to pass. So if you want to get into the AI, I'd say really start from the fundamentals and try to come up. Don't start with a big deep network that you just run and train, because you're not really going to understand. You can execute the code, that's fine, but then you won't understand what's happening inside. And now with things like Keras, a lot of what's happening is kind of hidden by these nice layers that you just sort of chain together, and that's cool if you wanted just to apply to AI. But if you really want to do research, you really need to understand what's happening underneath the covers. And to do that, you need to learn linear algebra. You need to get good at math and learn a lot of the old stuff that we used to learn in school back in the day. So there's a lot of good textbooks out there. I mean, I studied one Russell and Norvig AI book that I think I mentioned in my talk. I think it's still being used. Yeah, artificial. I think that's a good textbook. It's pretty broad and comprehensive, and it's not just. I think they've added the new edition has deep networks, but it goes over a lot of things. So that's where I learned about evolutionary algorithms, and it goes to things like just planning and A star and things like this that don't. AI is more than just deep networks, and there's a lot of interesting problems that arise there, and there's a lot of people that are working in AI that are not using deep networks. And so the more you know about all these fields, you might find there's one particular field that doesn't even touch deep networks that you're really interested in, and that will give you the door to how to start investigating that a bit more.
What are the main differences between research in academia and in companies like Google, Fair, DeepMind, and so on?
It's a good question. I think the terrain is changing quite a bit. So one thing I'll say is there's different types of research within industry. So at Google, there's many research groups. Some of these are applied to a particular product. So for instance, in my office, when we used to go into the office, some people on my floor were working on Google Translate. And so there are researchers that they publish in ACL and all the EMNLP and all these big natural language conferences. But the research is they have a focus point, which is Google Translate. And there's other research teams that are doing things like all the advances you see on the Pixel phones and on the cameras and things like that. There's research teams that are working on that. Not necessarily AI, but a lot of it nowadays is. And then I'm in a team, Google Brain, and we're just doing pure research. So we're not tied to any product. And the idea here is that it's basically allowing us the opportunity to explore new things without necessarily having a North Star of a particular product, because when you do that, you might uncover some really new ideas that you wouldn't have come across necessarily had you been trying to optimize things for a particular product. So for instance, the transformer, which is probably one of the most popular natural language processing architectures that people are using today, this came out of Google Brain. And now it's used in Translate and in a bunch of other different applications that inside and outside of Google. And that came out of just sort of approaching natural language processing as a pure research task rather than trying to build something for Translate. Academia, on the other hand, I mean, this is just my experience from back when I was doing PhD. The advantages is you have a lot more freedom in a sense to sort of choose where you go because you're kind of in charge of your lab. So you, as a junior academic, I'd say you probably have more academic freedom, or you're more empowered to sort of drive your academic and research agenda than as a junior researcher at a place like Google, because here you're working with a lot more senior researchers, and so even though I have a lot of freedom, and a lot of other junior researchers do have also a lot of freedom, but you're not in charge of a lab when you start off. Whereas in academia, you start having students and taking in students and supervising them. That being said, that what I said at the beginning, the terrain is changing a lot. So we have a lot of these hybrid positions where people are profs at a university half of the time, and half of the time they're researchers at a big company. And so they get kind of the best of both worlds. I know a few people that are doing this. I've never done this. I don't know if that's a good thing or not. I'm not sure. But these types of new hybrid positions are being explored more and more nowadays.
Thanks. Now, Luciana Marquez's question is, what opportunities of research do you see for this intersection of art and technology?
There's a lot more happening, in part because of the power of generative models, and generative models, just the power of the things that they can produce, and the expressivity of these generative models, that a lot of the research that people are doing in that field, what they uncover is applicable not just to like creativity and art and generative models for that use case, but they're more applicable to other areas of machine learning and deep learning. So for instance, the Magenta team, they do a lot of really good research that gets published at iClear and ICML and NeurIPS. And they're still producing models that can then be used for creative purposes, but they're doing it in a very scientific way, in the sense that they're developing new techniques and new ideas that can then be extended to other cases that maybe don't necessarily lie in the creative field. For me personally, I approach this intersection of art and computer science and machine learning nowadays more from an artistic perspective rather than a scientific perspective. So I'm not as concerned with trying to get published in the big venues with the work I do in this field. I'm doing it more as an artistic expression. So there are some venues where you can publish it. Like there's every year for the past 3 years or so, there's been a creativity workshop at NeurIPS that I typically submit to. And there's a lot of really great work that happens there. There's other smaller conferences that are good venues for this kind of thing, like the International Conference on Computational Creativity that I presented at last year. So I was doing that for a bit, but nowadays I'm less interested in that side of things, because I'm not trying to necessarily advance science with the work that I'm doing right now. It's more, I guess, trying to find new ways of expressing oneself creatively and artistically with the marriage of, in my case, musical performance and technical tools built with programming. So there's, I think, both sides of it, both the artistic and the scientific, and you can sort of live in between or be at the extremes, and it really depends on what drives you and what makes you happiest.
Nice. Technology for human flourishing.
Sorry?
Technology for human flourishing. Right?
Yeah, exactly.
Okay, so Vitor Santana asked, are there opportunities for working with music generation using NLP techniques? Is this feasible?
Yeah, I mean, people are trying to do creative outputs with a variety of different techniques. So one kind of obvious one that comes to mind is lyric generation, right? So because it's natural language, then natural language techniques would fit nicely. And I actually have a project where I'm building this lyric generator using 2 transformer models. And it works pretty well. It works pretty well as long as you have your expectations set right. So the point of this thing is not that you press a button and you get your next top 40 hit. What I'm mostly interested in is tools that empower musicians and make them perhaps think in new creative ways and take them to new creative spaces that they wouldn't have gone on their own. And so that's the idea for that tool. It's, as a songwriter, if you want to get a new idea that kind of comes out of the blue, or something that you wouldn't have thought of by yourself, then maybe a tool like that can help you do that. So there's other people that are using this type of thing. I think that OpenAI jukebox thing that they released recently, I think they're using NLP for the lyric generation. I looked at it a little bit. Some of the lyrics, I think, were just taken from songs directly, but I think some of the other lyrics were generated, probably by their GPT-2 model. So you can use it for that. There are some other bit more experimental things where people try to use natural language techniques for music generation. I'm not familiar as much with that, but actually this makes me think of one thing that is a good example of this cross-pollination between, I guess, fields and applications, and why sometimes research that you build for something might be useful for something else, whether you built it for creativity or you built it for translating things. So the transformer model that's I mentioned is the most popular NLP model right now, or architecture. This was used recently by the Magenta team for the music transformer. which is basically a similar architecture, but it's for generating sequences of notes, so like piano performances. And it's amazing. It works really, really nicely, and it produces some really compelling pieces. And again, this architecture was not built for music generation, but because they're presented in this kind of general way, you can repurpose it for different things. And obviously, you have to tweak some things in the way things are represented. So I think they had to add relative positionings and things like that the original transformer model didn't have. And so the same architecture was also used kind of in parallel by OpenAI for the MuseNet model that they released last year, I think. So the NLP there's NLP as a task, and then there's NLP, the architectures and the models that are developed for that task. And so those models and architectures can be useful for many other fields that are just NLP.
Thanks. Gustavo Sutter has, what's your view on projects that aim to put creative machine learning in the center of the creation process instead of a tool that works alongside with the artist, as in your examples? And he says, thanks for the amazing talk.
Oh, thank you. Sorry, could you repeat the question? My daughter's
what's
phone
your
rang.
opinion on machine learning projects that are more about creating than about aiding the creation process?
As a musician, I don't really see the point of making something that makes music. I enjoy making music. I enjoy performing music. I enjoy practicing and learning. And I mean, if somebody makes a model that generates a piece of music, and that's its only purpose, then like I don't really see what was achieved at that point. If that's just a way to showcase the power of the architecture or the model, but it's not the end of this research project, then that's a different story. And that's kind of like what a lot of the people working in the generative space do. Like, this is a way to sort of demonstrate that their architectures are powerful enough and expressive enough that they can produce compelling pieces. But the end goal is not to, at least of the people I know, the end goal is not to have something, a robot that then writes music for you, because as a musician, that would pain me to see. And I mean, in a sense, we're kind of going towards that path. Like, a lot of pop music is highly produced, even though there's still humans behind the controls, like with things like auto-tune and auto-quantize, and yes, they produce super tight pieces, but for me at least, this is just my personal aesthetic, it takes away a bit of the soul of what it's like to perform live with other musicians. And I mean, I think people will disagree. And again, this is just a personal aesthetic choice. But in terms of having a model just produce the song for you, like, other than saying, wow, that's amazing, I wouldn't be drawn to that. But again, that's just my personal thing. So to answer the question, I'm way more interested and almost exclusively interested in developing these technologies to work alongside an artist. But the artist is always in control.
Yeah, like that. Intelligence augmentation thing from Michael Mason, right?
Yeah.
Okay, so Bruno Coelho asked, would you recommend summer internships during a PhD or doubling down on research?
I mean, there's research internships. So actually, nowadays, a lot of PhD students do research internships. When I was doing my PhD, that wasn't a thing. So we just stick around in our labs doing research. Some people would. I think I did one summer internship in the company I had worked before joining grad school, just for money, but it was just programming. So my research, basically, I had to pause it. But nowadays, there's research internships at all the major companies. So I've had interns the past 2 or 3 years, research interns. So with my intern from last summer, we have a paper under review at ICML. My intern from the year before, we got a paper published at AAAI. And then there's my colleagues also have their own interns that they've been very successful. So for for us, it's nice because we get new people to work on interesting projects with, and for the students, it's really great because they work on something that's likely not what they're doing their PhD in, or not exactly. So they get some extra exposure. They get exposure to other researchers, which is always good if you're on the job market because you have more reference letters. And yeah, there's a lot of opportunities out there, and not just at the big companies. There's research internships at many of other smaller companies.
Okay. Now, Gustavo Sutter again has, do you have any tips for students from South America that want to pursue a master's or a PhD in Canada?
Sorry, what was the first part?
Do you have any tips for students from South America?
I think in Canada specifically.
Yeah.
I think again, it goes back to whether you know what you want to do your research in, or if you just want to do a master's, which is also fine. So if you know what you want to do your research in, it's a little bit easier because then you can go by what profs are working on the research topic you're interested in and then sort of approach them. If you don't know what you want to do your research in, I mean, I often feel that having more options is more difficult because it's harder to make that choice.
The paradox of choice.
Yeah, exactly. I mean, there's a lot of good universities out there. I'd say just do your research and look at the different universities. Also look at costs. I mean, at the end of the day, you do have to be kind of pragmatic about it. Some universities are more expensive than others, and so depending on your financial situation, some might be like just out of your budget and not really realistic. So in that sense, it limits your options. If you do have any university at your disposal, or you think you can get a scholarship, there's often lots of scholarships out there. I'd say try to see like which university, if financially you could go to any, try to find the best universities, I guess, that you can go to. Also couple this with the cities, what city you will be in. So Montreal, I ended up in Montreal sort of by chance, but it's an amazing city and I love that city and I would recommend it to anybody. So the other thing that I would recommend is now there's more and more of these events that try to reach out actively to underrepresented groups. So there was Kipu last year in Uruguay, which I think you were there, right, Joel?
Yeah.
And there were other people there. And so some of us from North America went down there, and there's other events like this. There's RIA in Mexico that I was also there last August, and there's other smaller events that happen throughout the year. So if you can go to some of these, it's also a great opportunity because often you'll find researchers and academics that are in North America or Canada or Europe or wherever, and reach out and talk to them. If they're there, they're usually there because they're open to talking to people and they're usually friendly and willing to help out. So just reach out to them, tell them about your research interests, where you are, and they'll try to help out. I mean, they might not be able to help out all that much because it might not be their field of interest, but they might be able to point you to somebody that who could help you out. So really being proactive in terms of reaching out. It's I know it can be sometimes difficult or daunting coming from like South America and trying to break into North America because there is a bit of a bias that we're trying to break with a lot of these conferences, but it is people in North America do have an easier time getting to these places for multiple reasons. And so when you have these opportunities with these smaller conferences, I'd say reach out. So as an example, this one student that I had met through a few of these events throughout the years, and he reached out to me and kind of kept in touch, and we wrote for a bit. He ended up applying to do a master's at University of Montreal, and he got accepted, and so I'm going to be supervising him starting in September. And this happened because he was proactive about it, and he reached out, and any opportunity that we were in the same room, he'd make it a point to come talk to me, and we'd discuss research. And so that type of thing does help. If you have sort of an ally that's trying to help you out. I mean, often the other thing is not everybody's going to be able to help you. So just reach out to as many people as you can, and yeah, and hopefully something good will come of that.
Thanks. And I think this is the last one. Do you think that South America's markets have a good future on machine learning and AI?
I think so. I mean, yeah, I think there's a lot of opportunity for a lot of the methods that are being developed with AI and deep learning. They can solve a lot of really interesting problems. The important thing is that the people that are trying to use these technologies, or the companies that are trying to use these technologies, the policymakers, the decision makers, I think it's really important for them to have a pretty good understanding of what they're using, because even though these tools can be very powerful, they're not magical. So if you feed it in, for instance, a classifier, if you feed it in extremely biased data, the classifier will be biased by definition. And so understanding that is something that, if you're not at least somewhat versed in how these methods operate, even if at a high level, you might expect it to just kind of get rid of the bias magically. So I think that's really a key thing that is starting to improve in South America from what I can see. And a lot of this is mostly from my experience in Ecuador, where I'm from, and in Peru, where my parents live now. There are a lot of efforts to try to educate more and more people, but and you see this everywhere in the world. Because there's such a big hype around AI, people often have a tendency to try to go towards the AI solution just because it's what everybody says. And so sometimes AI is not the solution. I mean, in many cases it is, but in many cases it isn't. And so really understanding the problem and getting to know your data and your customers is key to making sure that you implement the right thing and that you'll do it correctly. So I've given this workshop I give it at Mexico and at Quito as well in Uruguay. It's called the People and AI Research Workshop. And it's a workshop meant for people in industry that are interested in AI and trying to understand how to use AI, and sort of walking them through the workflow of how you would go about trying to make these decisions in an informed way. So it's been pretty successful. I think there's a website, if you look for PAIR, Google, I think it's called Pair with Google or something like that. Those types of tools, I think, help more and more people get familiarized with the subject. So all that being said, as long as people are well educated, I think there's tremendous opportunity for AI and machine learning in Latin America. And I think the more people like us that are getting educated in this field will have a lot of opportunities to be able to deploy this in a responsible and efficient way.
Okay, so those are the questions. Thank you very much. Thank you very much.
Thank you.
For the
Thanks
talk.
for inviting me.
It was amazing. And
thank you.
Bye.
All right. Bye. Have a good day.